We have already finished adding the loads. So if you will look to edit load cases, we'll find that there are main 8 loads that act to our building, our construction, sorry. So own weight, payload, snow, ice, wind on axis X, wind on axis Y, and the pulsation on X and the Y axes. So also we added foundation to our metal tower. We added ground soil conditions. So we also restrained the edges of the column foundations on the X and the Y direction. So on Z direction, so under the foundations, there are the model of subgrade reactions C1 and 2. So we calculated it and accepted. So now the next step is before we'll make analysis, total analysis of the building, it will be adding the hingers for our elements. So hingers is an important part for tower constructions, for space constructions, like trusses, arches, steel towers, and so on. So how we'll do it? We need first of all, so how we can quickly do it. On the previous video, we separately selected each of the element and tried added the hingers. So now I will show you the more quickly way how to do it. We need to first of all select the main legs of the tower. So the pipes, 3 pipes with 3 various dimensions. So we have already selected it. And now by choosing select nodes and select the elements, I will select all tower without foundations. And use the option fragmentation. So here I see all needable elements for which I will accept the hingers. So not only for pipes, for all other I need to add the hingers. So I will select them, go to bars, hingers, and will use in first node and second node the hingers, and will apply. That's all. We'll restore model. We'll pack it, save the model, and play bottom analyze. So we need to wait some moment. Okay. Let's see. Important thing. Analyze is completely finished. Okay. Let's go to steel. Let's see the occurrence coefficient. So according to the first limit state, so here as you can find the mosaic results, according to the first limit state, we see that there are more than 60% accuracy coefficient. It is very good results. Second limit states for serviceability. Here we see about 2.6 accuracy coefficient. Запас прочности. About 2.6%. Okay. And here checking for the local buckling, so it also stable. Let's see our reinforcement for our monolithic constructions. So for plate of the column foundation basement, it will be enough to use 8 millimeters reinforcement, and for the column part, it will be enough to use 10 millimeters in diameter of the reinforcement. Okay, so that's all what we need to make during the calculation of the metal tower. And the last step will be create the report. So in the report, we need to show all results, all our steps, what we did, how we did it, and so on. Because we can show to our customer this program and this calculation. He needs to use the readable document which will be convenient to read and to use in the, for example, construction site, or maybe in the design organizations and so on. So what we need, first of all, it is to open the MS Word document and write here the name of our construction. So metal tower or calculation of metal tower. We can put here the main view of this tower. Let's go to the 3D model. So 3D model, we can show real sections. So here is our ready construction. Now we can add the option report books, and this report books can help us to make the screenshot. Make the copy of this screenshot, go to the explanatory note, and I will put the screenshot of our town. Here we write the city where was prepared calculation and the year. Then introduction. Introduction can be took from the document LIRA SAPR. We need to open still, and here is documents. In the documents there are explanatory notes. So explanatory notes include introduction. So we make the copy of this introduction. Go to our explanatory note. And change this Russian information into English. Then actually you need to make some correction box. You need to make some correction. Okay, then you need to write information about your construction, initial dates, about your volume planning and constructive solutions from your building. So in what snow region it was calculated. So for this you can open your task. In the task you can find all information. So here is your table number 1 where you applied your sections according to last digital from your ID number. According to your first letter, you accepted your loads for the building. So make the copy of this, or maybe just delete not needable tables, columns, and just save the needable column with your number. Then make the copy of wind load, because on these tables we have already made all our calculations. You can make the copy of all these dates. Then you will be able to translate it into English, because it was prepared in Russian. But when you will final pass your explanatory note, you will need to pass it in English. So here you'll put the general information about your building. You can put some drawings from the AutoCAD file. Also can be done quickly, just copy and paste. So here is, you will put your own loads, dead loads, live loads, short time loads, and so on. And here the live loads, you will copy from the previous documents, wind load, snow load, ice load, and put it here. Okay? Students?
Okay.
Okay, so it's not difficult, right? Next, then you will be able to show the views from X, Y, and Z side on your construction. Again, you need to make the copy of your print screenshot. So open document LIRA. This will be the diameter projection. Here will be projection on X or Z plane, from X or Y plane, and the last one Y or Z plane. So make 3 of these photos, screen shots, and put it, first of all, actually copy it and then paste it to your explanatory note. Something like this. Next, you need to put your stiffnesses. The table with the stiffnesses. The table with the stiffnesses can be taken from again from the documents and the interactive tables. Use the interactive tables. Here you can find the form editor. Here you can find the properties. Play apply, and you will find your stiffnesses property table. Press file, copy to Excel. Oh, maybe not copy to Excel. Save file for Excel. Save file for Excel. Then choose on your work table the document where you will save the Excel file. Save it. Then go to that document and open it. Oh, it's not that file. Okay. So here you can add the lines for your table. Then you can make the copy of this table, and you will put it into your explanatory note. So this table can be deleted. So there are no reason to use this information. You can delete it. Next, the main results about calculation. So the main results can be took from the documents, standard tables, analysis protocol. This protocol, you make the copy, Control C, or maybe just copy, press copy button. Let's go to this, delete old information, and put new one. Firstly delete it, and then put it. This information we doesn't prepare because it is for a seismic load. It can be also deleted. So delete it. Next, the deformation schemes. So deformation schemes can be taken from the program itself. So we need to go to results. First of all, we need to work with the scale of displacements, and we need to decrease it. Decrease it in 5 times. It will be enough. Now, you need to show deformations in along z-axis from the all static loads. You need to show the displacement in the millimeters. So this is line with the various colors show us the dimensions of displacement. Make the screenshot, copy it, and paste to the explanatory note. Here is from own weight. Right here, deformation scheme from own weight of construction. Next, deformation scheme from pay load. Go next. Change the load. So in the bottom part of the program, you can change the loads, and you will see that the load is changed and the displacement also changed. Again, you need to make the screenshot, make the copy of it, and paste it to the explanatory note. Just write here that it is deformations from the payload, and so on, and so on. What about wind load? Wind load on x you should shown on xx. So here you see the displacement on z-axis, y-axis, and x. So show these results. The next wind load on axis y show deformations on y-axis. The pulsation on x show on pulsation on x. Pulsation of y-axis show with y-axis. That's all. Next, when you will finish showing the deformations, you will start with the reinforcing of your monolithic column foundation. Here you can find um, reinforcing of constructions. So you will write here reinforcing of monolithic column foundation, the plate, and we'll start showing the you can make it in the next step. First of all, you can select the plate, make the fragmentation, go to reinforcement concrete, and to show the reinforcement on X and Y directions, along X and Y direction. Next, when you will make the print shot, put it into your report, then restore model, select the rebar, so it's a column part of foundation, and show reinforcement for it from 4 parts of the rectangular, square column. Again, make the screenshot, copy it, and paste to the your report. And after then, you will finish it by making screenshots of the first limit state, second limit state, and last of local buckling. And of course, you can put here the checking of accepting cross sections. So the sections what we have selected, how they answer to the how we accepted it. So it shows right we accepted it or not right in the coefficients. So we see that it's not higher than limited. The next one, it is cross sections for serviceability, and the last one, it is the sections which was accepted by the program. So actually sections which program helped for us to accept, you can find here. So in general, I can change my sections to these sections. And so we'll see for some of the limit states that coefficient will be some less than it was now. So this occurrence coefficient, for example, let's see. Here as we see that occurrence coefficient about 60%. So if you will change the sections on less size, so which was give us by the program. Actually, this coefficient, occurrence coefficient will be less. So it will be near to the 100, and so it will less than it was when we applied just according to our task. So make the print screens of all these 6 positions and put it into your explanatory note. So that's all what you need to take from your calculation, from the program. Actually, you can write the conclusion. In the example of report, you will not find it. You can write it by yourself. So how was calculation done? what the main results of this calculation, and so what you will think about what you need to write, you can write it in the conclusion to the explanatory note. Okay, if you will have questions, I will try answer it and help you how to prepare the explanatory note, how to prepare report for this calculation. Because in general, our calculation is finished. Who have questions, maybe or not?